4 specific membranes that play a role like an organ would. 3 of those 4 are true organs. The 4th one is not, but they still call it a membrane. And so what we're going to talk about with each of these membranes, and I didn't make a table for you. I thought about it, but I'll let you make your own. We're going to look at the different types of tissues for each one and kind of talk a little bit about their purpose. Okay? So the first type of membrane is a cutaneous membrane. And I'm really not going to say a lot about that because that's what Chapter 6 is about. It's the skin. The skin is what we call a cutaneous membrane. It consists of a layer of epithelium and actually 2 layers of connective tissue. The epithelium is called the epidermis. The connective tissue is called the dermis. And those terms are terms that you should be somewhat familiar with already. The epithelium is stratified squamous epithelium. We have a very, very thin layer in the dermis of loose connective tissue. Very thin layer. The majority of the dermis actually is dense, irregular connective tissue. And we'll get into specifics about these tissues again in Chapter 6 on Monday. Now, the other type of membrane, this one here, is called a mucous membrane. And this one down here is a serous membrane. All these membranes that we're going to talk about do produce some type of secretion. The cutaneous membrane secretions are sweat and sebum for the most part. Mucous membranes produce mucus. Serous membranes produce serous fluid, a water-based fluid. All right, so let's talk about a mucous membrane. This here is showing the esophagus as it protrudes through the diaphragm before it enters into the stomach. What we're showing is the different, this is an entire organ, but the mucous membrane of the digestive tract would be this layer of epithelium here, this pink layer that lines the lumen. The lumen is the hollow space of a tube. So this epithelium here, in the small intestine, it's going to be simple cuboidal. It does vary a little bit from digestive organ to digestive organ, but that's followed by a thin layer of loose connective tissue. And then this little pink reddish line here is a very thin layer of smooth muscle. Very thin layer of smooth muscle tissue. You can actually see it a little better here. So what this represents is this here. Let me draw it on the screen here. It represents this right here, from here to here. This is all mucous membrane right in here. And that's what we're seeing here. So here's your epithelium, and that's going to vary. If you're in the respiratory tract, you're going to have pseudostratified ciliated columnar epithelium with goblet cells. If you're in the digestive tract, small intestine, you're going to have simple columnar with goblet cells. You remember seeing the goblet cells when you looked at the small intestine slides? This is the loose connective tissue that those epithelial tissues are connected to. And then this is that very thin layer of smooth muscle. This layer of smooth muscle is called the muscularis mucosae. Tubular organs within the body, mainly in the digestive system, but respiratory, we can kind of associate them as well, have 4 layers. They have a mucus, or what's called the mucosa, submucosa, muscularis, and then serosa. This muscularis mucosae, this whole thing here, would be what we call the mucosal layer of the trachea or the mucosal layer of the digestive tract, because it's a mucous membrane. It's epithelium, loose connective tissue, and in the digestive tract we have this. In the respiratory tract we don't have this here. But so you can have 2 to 3 layers in a mucous membrane. The third layer would be this smooth muscle tissue. Now this here is the serous membrane, also known as the serosa if we're talking about the digestive tract. If you were to open me up the layer of tissue that you're seeing on my intestines, that would be the serosa. That would be this serous membrane. So this outer layer here, this pink layer right on the outside edge here, it's kind of peeled away right here. That is a serous membrane. Specifically in the digestive tract, it's called the serosa. Just like the serous glands, these serous membranes secrete a serous fluid, a very watery fluid. This is important because another name for this serous membrane on any organ would be the visceral membrane. So if we're talking the digestive system, it would be the visceral peritoneum. If we're talking the respiratory tract, the lungs, it would be the visceral pleura. If we're talking the surface of the heart, it would be the visceral pericardium. So these serous membranes, not only do they line the outside of organs, they line the walls of body cavities as well. So those parietal and visceral membranes we've talked about back in Atlas A, those are examples of these serous membranes. The parietal and visceral membranes are examples of serous membranes. Now, another term for these parietal and visceral membranes, and the fact that it's simple squamous epithelium and a loose connective tissue, is called mesothelium. Mesothelium. Stay home sick with one of your kids one day for school, watch daytime TV, and you'll see 100 commercials that say pretty much this: have you or a loved one ever been diagnosed with mesothelioma due to asbestos exposure? If so, you may be entitled to monetary compensation. That's what they're talking about. Cancer of these parietal and visceral membranes. That's what mesothelioma. I said mesothelium. Mesothelioma. But another name for these membranes is the mesothelium. So if I use that term, you immediately need to think parietal visceral membranes. Parietal visceral peritoneum, parietal visceral pericardium, parietal visceral pleura. And if you're not sure what those are, you need to go back to Atlas A. Now these are serous membranes because these two membranes, the parietal and visceral membranes, come together here. And these organs, as I mentioned before, move around. And so there has to be some type of lubricant there to reduce the friction that can be created between the two membranes. And that's what the watery-based serous fluid is for. Now this here is a picture of the heart. It's showing us the parietal and visceral layers of the heart. This layer right here is the visceral pericardium. And this layer here, actually I can show you here. This is a close-up. This layer here is the visceral. This pink layer here is the parietal. And there's a little space in there, and that space is filled with serous fluid. Now the heart actually has two serous membranes in the organ itself. We have the visceral pericardium, which is also known as the epicardium. It is just a layer of simple squamous epithelium and loose connective tissue. Very thin. That's what serous membranes are. Simple squamous epithelium, thin layer of loose connective tissue. But the lining of the heart chambers themselves, in the ventricles and the atria, that's called the endocardium. It's still a serous membrane. It's still a layer of simple squamous epithelium with a very thin layer of loose connective tissue. And that's how this simple squamous epithelium adheres to the muscle. This is the muscle of the heart that does the contracting. If we look at blood vessels as a tube, the layer of tissue that lines blood vessels, that forms the simple squamous epithelium that the blood comes in contact with, is called an endothelium. It is also a serosal membrane. Capillaries are just endothelium. That's all they are. Endothelium and a basement membrane. Maybe some loose connective tissue holding that to the, to the cells around it or something that it's supplying. But so endothelium is also a serous membrane. The last membrane is called a synovial membrane. This is not a true organ because it's only made up of connective tissue. These are found associated with the joints where bones come together. They secrete a fluid called synovial fluid. Again, the synovial fluid, like the serous fluid, helps to lubricate the ends of the bones so that when the bones move, it reduces the friction and hopefully you don't have any pain associated with movement. So these synovial membranes span from bone to bone here and enclose the space between the bones so that that fluid that they secrete can stay in there. We'll address this a little more depth in Chapter 9 when we look at those articulations. All right, I'll give you a couple minutes here before I move on to just kind of look through what we talked about as far as cell connections, glands, and these membranes. Ask any questions, and then we're going to move on and finish up Chapter 5 here. Yeah. When you crack you're actually changing the pressure inside, and it's actually cavitation. You're forming you're forming air bubbles in there due to change in pressure, and then they dissolve back into the fluid. So my chiropractor told me. I don't know. Don't crack their knuckles. Yeah, I don't.
I thought maybe it's actually just pushing the fluid out. You know what I mean?
No, it's staying in there.
Oh, okay.
But you're just changing the pressure inside because it's a closed space. So you're changing the pressure. By changing the pressure, you change the volume and things. American glands, sweat glands, tear glands, I believe mammary glands, gastric glands, glands in the stomach, and then holocrine would be sebaceous glands, Sebaceous. All right. Any questions in the back? Shh. Sure. I was kind of getting ahead of myself there, but the epicardium, the heart has 3 layers. It has a serous membrane on the surface. It has a layer of muscle, cardiac muscle tissue, and then it has another thin layer of serous membrane that lines the heart chambers. There's 4 chambers, the 2 top, the 2 bottom. The epicardium is that most superficial layer. The epicardium is actually the visceral pericardium. So when I said that those serous membranes are the parietal and visceral membranes, they are. In this case, in the heart, the epicardium is the visceral pericardium. We could also theoretically call it a mesothelium, which is just another term that describes these membranes. And these serous membranes are a layer of simple squamous epithelium and a very thin layer of loose connective tissue. This is a serous membrane. It's very similar, if not identical, to the epicardium. It's just found on the inside of the heart. In fact, that endothelium that lines the blood vessels is continuous with this. It's the same stuff because the blood vessels are directly connected to the heart. But because it's in the heart, we just call it the endocardium. So don't worry so much about that. I guess if you're going to take anything from this part of the heart, know that this superficial layer of tissue is a serous membrane, and it's a mesothelium, and it's also considered the visceral pericardium. And we'll get back into all this when we get into chapter 19, towards the end of the semester. Any other questions? Yeah.
So, I'm not a very smart guy, I guess. What's the benefit of having 3 names for this thing?
Well, it just helps as far as knowing specific location. If you said endocardium, endocarditis, inflammation of that inner lining of the heart. Okay. Epicarditis, inflammation of this layer here. Okay. Pericarditis, inflammation of the pericardium. That's part of it, just as far as understanding and communicating things. As a collective structure, this is a mesothelium, meaning it's a membrane found on the surface of an organ or on the wall of an organ, or a wall of a body cavity, that's simple squamous epithelium and loose connective tissue. Anatomists like their terms, I guess. When I was taking my gross anatomy course at Grand Valley a few years ago, there was 4 different terms or names for the same structure. There was a name of a person who discovered it, and then the regular name, and then there was a third name sometimes. And you had to know all of them. So you will hear those terms. So it's important that when you hear them, you do know that they are a serous membrane, and it's part of what we call the mesothelium. Any other questions?